Hello students, welcome all to my midterm math class. Students, NDA 2 exam is approaching, just 13 days are left. Those who are appearing this examination, for them I suggest that don't take so much pressure, as well as don't go to new topic also. Whatever you done since last 1 or 2 years, just follow, keep patience and regularly practice. And you have to follow also PYQ, very important. And mostly, that is very important, you have to believe yourself so that you can bring more confidence regarding this examination. Okay students, and also if you have any doubt regarding other topic also, just comments below so that I can make for that topic also. Okay students, hope you understand. So let's start the class. Students, today I am going to discuss about limit theorem. Some basic limit theorem be there, and that theorem, that formula is very useful when you will solve the 0 by 0 form. Okay, so look at this limit theorem. That is, there are some 9 important basic theorem be there. You can note please. First property or first theorem is limit x tends to 0 sin x by x equal to 1. Number 2, limit x tends to 0 tan x by x equal to 1. Number 3, limit x tends to 0 1 minus cos x by x equal to 0. Number 4, limit x tends to 0 logarithm function log 1 plus x by x equal to 1. Number 5, limit x tends to 0 e to the power x exponential function minus 1 by x equal to 1. Number 6, limit x tends to 0 a to the power x constant to the power variable minus 1 by x is equal to log a. Number 7, limit x tends to 0 sin inverse x by x equal to 1. Number 8, limit x tends to 0 tan inverse x by x equal to 1. Number 9, limit x tends to a x to the power n minus a to the power n by x minus a equal to n into a to the power n minus 1. So these 9 theorems or property very useful when you will solve the sum limiting value finding case. Okay, so you have to remember these theorems. And when this formula theorem used, basically when you see that the quantity is your rational form, px by qx form. The quantity, this is your rational form, as well as the form is contained 0 by 0 form. 0 by 0 form after using the value, putting the value x. Okay, and if you see also, if you see numerator and denominator, both function, denominator both function don't have any common factor, If you see numerator and denominator both don't have any common factor, and you see that the form is rational form as well as 0 by 0 form. So when we evaluate the limiting case, in that situation you can use these important theorems, 9 theorems, 9 properties. You have to remember these properties for finding this type of problem. Okay, when you see the quantity rational form as well as 0 by 0 form, and numerator and denominator both don't have any common factor, that time you can use this theorem. Okay, so copy please. So now comes to your indeterminate form. When you see that quantity in form of indeterminate with 0 to the power 0, infinity to the power 0, 1 to the power infinity, this type of form if you see, so that time how we have to solve, let us discuss. Okay, so if you see the number 1 first case, for quantity is 0 to the power 0 or infinity to the power 0, so in that situation how we have to solve? If you see that, first I take, let the quantity, the form is fx to the power gx, and limit x tends to some quantity c, let us take x tends to c, and that limiting value let us take small l. Okay, so and the form is 0 to the power 0 or infinity to the power 0, either 0 to the power 0 or infinity to the power 0. So that time if I take x tends to c fx to the power gx equal to n, that time you have to take both sides logarithm Okay, so if you take both side logarithm, so you see that log of, or you can write ln both side log l, taking log. Okay, so if you see function to the power function and that form is 0 to the power 0, infinity to the power 0, that time you can take both side log. Okay, so or you can log x, you can represent also ln x. Okay, so now the property, you can use the property of logarithm. Now power is comes outside, so limit x tends to c, that is gx log of fx is equal to log l. Okay, so in that situation we have to use that type of form. Okay, if you see that the form is given and from fs to the power gx and quantity also 0 to the power 0 or infinity to the power 0, that time you have to take both side logarithm. Okay, so copy please. And also this can use infinity to the power 0. Both case you have to take log function. Okay, so copy please. Okay, comes next. Now second part for 1 to the power infinity case. Okay, so if you see that limit x tends to c fx to the power gx, function to the power function in the form of 1 to the power infinity, and if you take the limiting value is l, that time that time you can again use logarithm. Okay, logarithm, you can take both side log fx to the power gx is equal to log of l. That situation you can use one shortcut form. You can remember that form. That is very important step. You can see limit x tends to c, this gx comes to outside, gx into fx minus 1 form. You can write like that way. Okay, so very important form. If you see the quantity is your fx to the power gx form, as well as quantity form is 1 to the power infinity. That time directly you can use shortcut form, that is this upper form, that is power form, comes to outside, and main form fx minus 1, that limiting value you can use is equal to log of l. Okay, very important shortcut form, you can note please. Okay, now comes to some example. You can see that there are 3 example I written here. That is, first example is limit x tends to 0 x to the power x, you have to find. And second is your limit x tends to 0 1 by x to the power x, you have to find. And third is limit x tends to 0 1 plus x to the power 1 by x, you have to find. So this type of, actually the quantity is of the form 0 by 0, infinity to the power 0, 1 to the power infinity. Okay, so comes to your first solution. You can see that is limit x to the power 0 x to the limit x tends to 0 x to the power x. Okay, so if you substitute x tends to 0 here, so you see that 0 to the power 0 form. If you substitute x0 here as well as x0 here, 0 to the power 0 form this quantity. Okay, so that time you have to use your logarithm. Okay, so let same form, limit x tends to 0 x to the power x is equal to small l, both side taking log, limit x tends to 0 log of x to the power x is equal to log of l or ln l, limit x tends to 0, that is power outside, log property log of x, that is your log of l. Okay, so property, you know that log property is log m to the power n is equal to n log of m. So that property you can use here. Okay, so now you see that this is your x and log x. Okay, so how you can represent? If you substitute here 0, and if you see your log 0 and log 0 into log 0, that is not possible. So that how you can represent? Limit x tends to 0 log x by 1 by x. That x comes to your denominator form 1 by x. Limit x tends to 0 log x by 1 by x is equal to log of l. Okay, so this x represent by 1 by x. This is your quantity form. We have to represent some quantity form, so that x represent by 1 by x. Okay, so copy please. Now we have limit x tends to 0 log x by 1 by x is equal to log of l. Now if you substitute 0 here and 0 here, you see that log 0 as well as 1 by 0, that is your, you see that log 0 is infinity by infinity form. So that time you can use your L hospital rule or L'Hopital rule. You already No, because I already discussed. If you substitute here 0, if you substitute here 0, so log 0 is infinity and 1 by 0 also infinity, that is your 0. Infinity by infinity form, that time you have to use your L'Hospital rule, or that is your L'Hopital rule. So derivative, so you know that derivative of this log x is 1 by x, and derivative of 1 by x equal to minus 1 by x square, right hand side log x, because you know ddx of log x is equal to 1 by x, and ddx of 1 by x is equal to minus 1 by x square. Okay, so now just calculation part. So x1 x cancel, so you got your minus x is equal to log of L. So that means if I substitute here 0, so log L is equal to 0. So you found that log L, log of L is equal to 0. If you substitute here 0, so log L is equal to 0. So copy please. Now we have log of L is equal to 0. That means that is basis E. So you can represent like that way. L is equal to e to the power 0, e to the power 0, and something to the power 0 is your 1. So limiting value, it goes to 1. So that means limit x tends to 0, x to the power x is equal to 1. So in that way, fx to the power 0, fx to the power gx form, as well as some 0 to the power 0 form or infinity to the power 0 form, that time you have to use both side log, and in that way you can solve this type of problem. So answer is your 1. Limit x tends to 0, x to the power x is equal to 1. Okay, copy please. Now comes to your another problem number 2, that is limit x tends to 0, 1 by x to the power x. You can say let L. Let us take L. If you again substitute here is 0 as well as here is 0, you see that that form is infinity to the power 0 form. Infinity to the power 0. If you substitute 0 here, 1 by 0 is infinity. As well as if you substitute here 0, so infinity to the power 0 form. Again, if you see that, if you know that, you already know that the quantity, if quantity is infinity to the power 0, infinity to the power 0 means you can again use both sides taking log. Okay, so again log, that is your log limit x tends to 0. You know both sides taking log of 1 by x to the power x is equal to log of L. So this implies that is x outside, limit x tends to 0, x into log 1 by x is equal to log of L. Property, you know that log property is log m to the power n is equal to power outside n into log m. So that property we have to use, power outside log, and this implies limit x tends to 0, x into then log m by n formula you can use, log 1 minus of log x is equal to log of L. And also you know that log m by n is equal to log m minus log n, log m minus log n. So that property we can use here also. Okay, so log 1 minus log n. So this implies limit x tends to 0, x into log 1, you know that log 1 is 0, minus log of x is equal to log of n, that is your x. Okay, so this is your 1 by x. So x tends to 0, x into 0 minus log of x, because you know that log 1 is equal to 0, log property, log form. Okay, so that is your 0. Okay, so you got limit x tends to 0, x into 0 minus log x is equal to log of L. Copy please. Now we have limit x tends to 0, x into 0 minus log x is equal to log of L. So that means you got the value limit x tends to 0, x0, that is x into minus x log x is equal to log L. So minus outside, minus of limit x tends to 0, x into log x equal to log L. In my previous that is solved, x tends to 0, x to the power x, same quantity became. Okay, so you can check also. So that value you got your minus outside, and you solve that value becomes your 0, because limit x tends to 0, x log x represented by, that is your 0. Okay, so how we already I discussed, that is x represented by log x by 1 by x, then infinity by infinity form. Just previous I discussed, you can check, that is log x by 1 by x, infinity by infinity form. Again L'Hospital or L'Hopital rule you can use. After using, we got the value 0. Okay, so minus 0, obviously that is your 0. So 0 is equal to log L, and you know that case how we can represent. If you log L is equal to 0, that means L is equal to, that is your Okay, so I can, so copy please. So now we have log of L is equal to 0, that means base of E, so L is equal to e to the power 0. So L value is your e to the power 0 is your 1, that is your L is equal to, that is L is equal to e to the power 1, that means limiting value x tends to 0, 1 by x to the power x is equal to 1. So in that way, infinity to the power 0, in that way you have to solve. Okay, so limit x tends to 0, 1 by x to the power x is equal to 1. Okay, copy please. Okay, so next, third part you have to find limit x tends to 0, 1 plus x to the power 1 by x. Let us take that is your L. Say, okay, so if you substitute here 0 and if you substitute x by 0, you find out 1 plus 0 to the power 1 by 0. That means the quantity becomes 1 to the power infinity. That quantity, you see that 1 to the power infinity. So I already discussed, if you see the quantity 1 to the power infinity, that time you have to use one shortcut form. That is, you can replace, and you know that that form is, if you see limit x tends to c fx to the power gx is equal to L. After that you can taking log. So limit x, if the form is 1 to the power infinity, that time x tends to c, you can write that is your gx outside fx minus 1 equal to log of L. Okay, if you take both side log, after calculation shortcut form, you got the gx outside fx minus 1 equal to log of L. That shortcut formula you can use here. So 1 plus x, so here also you see that 1 to the power infinity form. So taking both side log, limit x tends to 0, log of 1 plus x to the power 1 by x is equal to log x. So directly you can represent limit x tends to 0, or direct you can apply the form. Okay, so that is your, let us take, this is your gx and this is your fx. So gx outside, 1 by x outside, and fx is your 1 plus x minus 1 is equal to log of L. So that formula you can use directly. Okay, directly that formula you can use. This is your 1 by x, your gx, 1 plus is your fx. So formula is gx outside fx minus 1 equal to log of L. Here is L, but you have to take log of L. 1 by x outside, the quantity fx is 1 plus x minus 1 here. Okay, so clearly 1 cancel. Finally you got limit x tends to 0, 1 by x into x is equal to log of L. Clearly you see that x cancel. Okay, so directly one value you see that the value is 1. Okay, so copy this. Now we have limit x tends to 0, x into 1 by x is equal to log of L. Clearly x cancel, you got the value 1 is equal to log of L, and you know that log of L is equal to 1 means this is base e to the power L is equal to e to the power 1. That means L is your e value, e exponential value. So you can imply limit x tends to 0, 1 plus x whole to the power 1 plus x, 1 by x is equal to e. The solution is e. Okay, so because base of e, so L value is e to the power 1, e to the power 1 is equal to e, so the limiting value is equal to e. So in that way you can solve, that is 1 to the power infinity. Very important in that situation. In recent current situation, you see that the NDA papers contain mostly, whenever you see the question paper, indeterminate form given, that is your 0 to the power 0, infinity to the power 0, 1 to the power infinity. Also is infinity by infinity form be there, but this important, this 3 is very important. So in that situation, 1 to the power infinity case, directly shortcut form you can use and find the value. Limit x tends to 0, 1 plus x to the power 1 by x is equal to e. Okay, so copy please, and next class I again discuss about some important question regarding this indeterminate form. Okay, so next class we'll meet. Thank you.